There is now widespread awareness of, suspicion about, and even opposition to algorithms, as widespread as the many situations and domains in which these mysterious entities seem to be making more and more decisions around welfare payment claims, the fastest travel route at a given moment, what shopping coupons are made available to you, or the neighborhood's police patrol. Algorithms are also pervasive in media and communications. They build you customized magazines with news from several sources, help inform what movies you watch, the posts you see in your social media feeds, the way a matchmaking website pairs you with others, not to mention all that advertising and direct marketing. Media today are personalized, whether we want them to be or not, and we are becoming more than a little worried about these algorithmic agents that seem to be making it all possible. Their computational decision-making, their capacities at deep learning, so hidden, so obscure. But what if the politics of algorithms is not just about prying these black boxes open, revealing their internal biases, and perhaps correcting them? Instead, might it be that we need to understand the problematic social and cultural conditions from which these algorithms and associated technologies sprout up, get nurtured, and grow? Media Technology and Culture is a podcast series by me, Scott Rogers. In this series, we'll be taking a thematic look at media, understood as technologies. We explore the histories of media as well as more recent developments, and not always necessarily in a linear progression. Some of you listeners will also be students in my module, Media Technology and Culture, in which we'll discuss and work on some of these themes in more detail. This is the second edition of the series, which includes some new elements added to the episode in autumn 2021. In this episode, the ninth in our series, we focus on algorithmic technologies. The key idea I want to get across is this. The working of algorithms is opaque. And this raises a difficult question. What can we do to hold them accountable? One answer might be to better understand how algorithms work. But this alone is insufficient. We also need to think about the cultural conditions in which algorithms are intrinsically entangled. You're hearing UK students and teachers in August 2020 protesting outside Downing Street, residence of the Prime Minister. That year, amidst a global pandemic, final A-level exams had not been held. Ofqual, the regulator of qualifications in England, had opted instead to use a predictive algorithm which corrected teachers' estimated grades and rankings by taking into account performance at the school over the previous 3 years. Many students found the results downgraded, and in the ensuing uproar, the algorithmically adjusted grades were eventually abandoned. Today, it is more and more common to hear public concerns framed around algorithms. These often center specifically on media technologies, such as how algorithms make possible the potentially skewed information made visible to social media users, or the deepfake videos compounding already significant problems of misinformation. But this algorithmic frame is somewhat recent. A decade ago, concerns centered more so on the relationships of new technologies and personalization. In September 2010, popular technology magazine Wired proclaimed on one of its front covers that the web is dead. Wired were being playful with the fact that most readers at the time might not have really distinguished between the World Wide Web and the Internet, as we did in episode 6. On the inside pages, "Long live the Internet" was added to this proclamation about the web's death. At the heart of this September issue of Wired was a debate between prominent commentators Chris Anderson and Michael Wolff. Each put forward answers as to why the web was dead, or perhaps more correctly, who was to blame. For Anderson, it was us and our enchantment with the convenience, attractiveness, and reliability of more enclosed apps, platforms, and services that allow us to attain truly tailored and personalized experiences. For Wolff, it was them, the new media moguls like Steve Jobs and Mark Zuckerberg, who had finally found a way to make the internet profitable by duping us into believing that these new platforms were all about us. Aside from this blame game, Wired had probably tapped into an issue familiar at that moment to both academics and other analysts. that the web, an open space for discovering and sharing ideas, was quickly giving way to a more closed and finely tuned internet of platforms and apps, geared much more to our immediate tasks and desires. 1 year later, in 2011, Eli Pariser published his best-selling book, The Filter Bubble. You probably heard this term. It is now in the popular lexicon. To explain what filter bubbles are, Pariser starts with what he claims is their birth date, 4th of December 2009. On this day, without much fanfare, Google implemented its new personalized search.
If I search for something and you search for something, even right now at the very same time, we may get very different search results. Even if you're logged out, one engineer told me, there are 57 signals that Google looks at. Everything from what kind of computer you're on, to what kind of browser you're using, to where you're located, that it uses to personally tailor your query results. Think about it for a second. There is no standard Google anymore.
Pariser extrapolates the particular case of Google to digital and online platforms more generally. In 2011, most would have probably seen a social media platform like Facebook as inherently personalized. After all, you decide who you friend. Pariser, however, pointed out something most understand today but did not at the time. That platforms like Facebook filter the content you see in your feed based on a much wider range of signals than just who you friend. It is based on what you do on the platform. And might it then, for instance, hide posts from friends whose behavioral data indicates alternative political views from yours? Sure, media have long been personalized in various ways, but Pariser argues that there are 3 novel qualities to online filter bubbles. First, we are alone in them, because it is cumbersome to try and compare our experience of digital personalization with others. Second, they are invisible, since we don't really know what assumptions various services and applications are making about us, and whether they are right or wrong. And third, we don't choose them in the way we do other media. Filter bubbles are simply environments that we inhabit. These personalized filter bubbles, of course, do in some ways make our lives easier. They offer an automated route through the complex volume of information out there. But Pariser warns that filter bubbles are not just about being helpful to users. They are at the heart of an internet marketplace based on data mining. A service or platform knowing you is valuable not just for you. The metadata you create is the basis for targeted advertising and influencing your behavior. This is the extractive logic of platforms, which we return to in the next episode. Alongside data mining, algorithms have increasingly been seen as fundamental to these processes and applications that filter and personalize. But just what are algorithms? One relatable analogy used by computer scientists is recipes. A recipe gives you a list of ingredients, their needed amounts, and then a sequence of steps to arrive at the desired dish. An algorithm is something like that. It starts with data inputs akin to those ingredients and amounts, and processes them through a sequence of steps to arrive at the desired output. But this definition of algorithm describes virtually all computer programs. If you remember from episode 5, it stretches all the way back to the English mathematician and writer Ada Lovelace, who, with Charles Babbage, developed the first conceptual algorithm. The algorithms related to digital personalization are more complex because they involve various degrees of machine learning. In machine learning, those ingredients and amounts and that recipe-like sequence of steps is not entirely or even mainly stipulated in advance by human programmers. Instead, it entails providing the algorithm with sample data, such as words or images. This trains the algorithm to essentially build up its own sequence of steps. Machine learning algorithms perform calculations that human-programmed algorithms cannot, and exactly how they do this can be opaque. One of the most important ways algorithms are seen as shaping media culture today is via recommendation systems. These are a type of filtering that predicts what things, such as programs, music, restaurants, hotels, people, etc., a particular user might prefer or rate highly. It is based on data about, for example, who the user is, where they are, and the things that they have done. A good example is how Netflix presents users with suggested viewing content. The development of a sophisticated recommendation system has long been of chief importance to Netflix. Blake Hallinan and Ted Striphas, in a 2016 article in New Media and Society, describe the case of the Netflix Prize. This was inaugurated in 2006, when the core business of Netflix was still DVD rentals. The prize offered $1 million US to whoever could beat the accuracy of the company's existing recommendation system by a 10% margin. While the prize was awarded in 2009, neither it nor other suggestions made in the competition were fully applied. In part, this was because midway through the competition, the business model of Netflix began to shift to online video on demand. Users streaming content began to generate a huge amount of implicit behavioral data, overtaking the importance of explicit user ratings, which were at the heart of the prize competition. And yet, Hallinan and Striphas argue that the proposed algorithms of and public statements by Netflix prize contestants provide an insight into deeper cultural shifts at play. Drawing on Raymond Williams' 1983 classic Keywords, Hallinan and Striphas remind us that culture is an extremely complex notion. It refers to at least three things. First, particular modes for engendering human refinement, such as, for example, an art school or a gallery, which are governed by frameworks of value and authority. Second, quote, patterns of social difference, commonality, and interaction, end quote, or how groups do certain things. And third, the artifacts associated with different groups, and their aesthetic qualities. The discourses produced through the Netflix prize competition, they argue, indicate a set of transformations across all three of these registers. A transformation in which the field of engineering, in particular, is increasingly grappling and speaking with authority on culture. Hallinan and Striphas provisionally label this as the rise of a new algorithmic culture where, quote, computational processes sort, classify, and hierarchize people, places, objects, and ideas, and also the habits of thought, conduct, and expression that arise in relationship to those processes, end quote.
Hi.
Is Grandma there?
No, she's getting her hair done. What do you need?
Can you just go get her for me?
I'm really busy right now.
Well, just tell her to come get me.
Why?
Because I don't feel good.
Well, have you talked to the school nurse?
No, she doesn't know anything. Will you just come get me?
No.
Well, will you do me a favor then?
What?
Can you bring me my chapstick?
No, Napoleon.
But my lips hurt real bad.
Just borrow some from the school nurse. I know she has like 5 sticks in her drawer.
I'm not gonna use hers, you sicko.
See ya.
Ugh. Idiot.
One way engineering rationalities might be seen as suffusing culture is in the implementation of statistical solutions to making recommendations. This potentially displaces traditional forms of cultural authority and canonization, such as film and television criticism. One way Hallinan and Striphas discuss this is via the Napoleon Dynamite problem, often cited in relation to the Netflix prize competition. Napoleon Dynamite was an offbeat 2004 film which divided opinion. This showed in its Netflix ratings, which tended to be polarized between 5 stars and 1 star. The film was an example of the difficulty in predicting user preferences for certain idiosyncratic content. The winning entry proposed a workaround, in which user ratings were measured in relative rather than absolute terms. It suggested an algorithm that would compare any given rating with other ratings the user gave to other films around the same time. In so doing, the recommendation system could arrive at what, from a statistical point of view, could be considered a more valid or true rating. Another important discourse, evident in the Netflix prize competition, argue Hallinan and Striphas, is a shift from traditional audience demographics towards behavioral measurement. This anticipated the later availability of more implicit data from video-on-demand users, mentioned earlier. Marketing has often relied on targeting categories such as age, ethnicity, or gender, but many of the prize contestants proposed mathematical methods such as singular value decomposition to model users based on subtler behavioral patterns. This would allow the system to identify users as, for example, someone liking action movies, but only where there are explosions, not too much blood, and possibly they don't like swearing. It put forward the notion, Hallinan and Striphas say, that machines might be able to see something in human behavior that humans themselves cannot. The potential of such new techniques in audience classification are shown in Netflix's approach to producing its own film and television content. Hallinan and Striphas point to House of Cards. Netflix outbid HBO and AMC after using its algorithms to determine that there was a sizable audience for this program. They estimated that different audiences would latch onto different combinations of the various qualities found in House of Cards. For instance, its enlisted actors, the style of its director, the specific genre, and so on. They had identified a large viewership via aggregations of, quote, highly differentiated micro-audiences rather than the lowest common denominator masses. But we risk losing sight of something important here. However sophisticated recommendation systems become, they still need users. All that behavioral data they collect comes from user actions in specific milieus. And the value of these systems is only affirmed when users take the recommendation and say, watch a suggested program. This is shown well in Daniela, Varela, Martinez, and Kaun's chapter in the 2019 edited book Netflix at the Nexus. They conducted a detailed walkthrough methodology, beginning with a close analysis of the Netflix interface, followed by think-aloud interviews where participants described what they were doing when using the service. They not only found users had multiple reasons for and ways of using Netflix, but also that users were generally aware of the recommendation system and at least some of its workings. Reading Netflix as a case of algorithmic culture requires us to understand the user practices entangled with its data-driven recommendations. In September 2020, several Twitter users experimented with the platform's automatic photo cropping. This is a feature in which, when an image is uploaded within a tweet, a cropped version is created to limit how much space gets taken up in the main feed. The algorithm decides what part of the image to focus on and is designed to ensure faces and text remain.
Right? So right here, you have a black guy on top, black guy on the bottom. Fine, you get the white guy in the middle. Maybe that's understandable for the first photo. Second photo. All right, fine. What's going to happen in the third photo? All right? White guy all the way at the bottom, black guy all the way at the top. For some reason, focuses on the white dude.
What users were finding was that if you uploaded a skinny and tall portrait image with a photographed white person at one end and a person of color at the other, the tool would almost always focus on the white person. Twitter claimed that it had done extensive testing for racial and gender bias before implementing the cropping tool, which used a saliency algorithm designed to predict the human gaze or fixation on any given image. A subsequent study by its own engineers could only find a mild bias in favor of white faces, as well as women's faces. Eventually, however, the platform established a $3,500 algorithmic harms bug bounty for anyone who could prove harms related to Twitter's image cropping algorithm. It is increasingly clear that racial biases are reproduced and reinforced by algorithms. In her 2018 book, Algorithms of Oppression, Safiya Umoja considers this problem through what has become one of our most ordinary daily activities via computational technologies: search. She begins with the case of a mother in 2011, Googling the term black girls. All she wanted to do was discover some fun things to do with her stepdaughter and nieces. The demoralizing result was suggested search terms which ranged from sexually explicit to piercingly judgmental. On the whole, they presented a troubling overall framing of modern black womanhood. While we might like to think of search engines such as Google as relatively neutral, the evidence suggests otherwise. Noble points to a problem that cannot be solved with a minor tweak to the design of the search algorithm. The privilege they accord to whiteness reflects the racialized power structures and data biases of the societies from which they come. And if these deep-seated problems are not addressed systematically, Noble argues, we face a highly pervasive, and in many ways hidden, reinforcement of racism and other forms of discrimination.
The world of artificial intelligence is affecting every aspect of our daily life. The beauty industry is no exception. Today, we would like to welcome you to the first beauty contest with an all-robot jury. Robots will look at your picture taken by a standardized app and compare you with millions of others. They will evaluate the main features including symmetry, skin color, wrinkles, and many other parameters affecting our perception of your beauty and rank you within your age group, race, and gender. Be the first human to win the beauty contest judged by robots.
In her 2019 book, Race After Technology, Ruha Benjamin picks up on a similar set of problems to Noble, but with the scope widened to include how algorithms and automation more generally are encoding new forms of inequity and discrimination into everyday life. Benjamin begins her first chapter with the example of a beauty competition that organizers said would be judged by robots. It turns out that the robots did not like people with dark skin. Of the 44 winners, only 1 had visibly dark skin, and only 6 were non-white. The contest organizers were using what, in 2006, was the most advanced form of deep learning, a subfield of machine learning. The robot judges, or algorithms, were fed a series of tagged images upon which they established the model of preferred beauty characteristics used in the competition. Benjamin argues that it would be a mistake to dismiss this beauty competition as superficial. More and more, we are seeing examples of algorithmic technologies embodying racialized structures, from the way an algorithm might factor race into life-changing decisions about a kidney transplant, to the ways Uber and Lyft pricing algorithms charge more in non-white neighborhoods. Racist robots, a term we should clarify Benjamin uses for rhetorical effect, quote, represent a much broader process, social bias embedded into technical artifacts, the allure of objectivity without public accountability. For Benjamin, there are a series of challenges to grappling with these racist robots. First is the universal standpoint assumed in deep learning, where the task at hand is modeling the human mind. What is seldom considered is that particular minds, particular points of view are being modeled. Benjamin shows a striking incarnation of this with a 1957 article in Mechanics Illustrated, which teasingly predicted slavery would be back by 1965, only to clarify that the slaves would be robots. The assumed value of mastery and the disposability of robots demonstrates, Benjamin says, the unacknowledged whiteness in early tech culture. Another challenge is dispensing with the idea that robots only become racist when they intentionally seek to harm. This reflects, Benjamin notes, a tendency to focus on overt racism when its structural manifestations can be more harmful. The same applies to addressing algorithmic bias. It is not simply a matter of pinning down that individual racist programmer or hiring more black programmers. Instead, Benjamin argues, we need a race-conscious approach to designing algorithms and automation, one that rejects the feigned colorblindness of the field. What follows from this appeal to address racist robots at a structural level is another appeal, to see the linkages between seemingly trivial and more consequential issues with automation. Benjamin cites a well-known viral video in which 2 men demonstrate how an automated soap dispenser fails to sense a darker-skinned hand while working for one that is lighter.
Nice. Okay, Noel, you try now. Come to your hand. 2 black or? 2 black. Yeah. What I'll do again.
While a technical assessment could be made of the flaws in the infrared sensor, that would not address why such a sensor was used in the first place. Seemingly trivial examples like this, says Benjamin, are comparable to the segregated water fountains of the past, providing a lens onto the wider social world. If the tech sector cannot get right simple forms of automation for cleaning our hands, how can we expect them to, for example, develop unbiased crime prevention algorithms for cleaning up a neighborhood? In her book's subtitle, Benjamin draws a parallel with the Jim Crow laws that were in place for almost a century after the end of slavery in the southern United States, which mandated separate but equal racial segregation in public facilities. With the new Jim Code, Benjamin argues new technologies are being deployed which, quote, reflect and reproduce existing inequities, but that are promoted and perceived as more objective or progressive than the discriminatory systems of a previous era, end quote. This growing literature, unpacking how algorithmic technologies embed social biases, particularly around race, reminds us that responding to problematic technical artifacts cannot and should not fixate on the workings of artifacts themselves. We need to think carefully about the social structures producing these technologies. Fabio Chiusi, from the nonprofit research and advocacy organization Algorithm Watch, noted in the introduction to the 2020 Automating Society report that those protesting students, the ones I mentioned at the start of the episode, quote, were not chanting against the algorithm in an outburst of technological determinism. They were motivated by an urge to protect and promote social justice, end quote. They framed their disquiet around the abusive use of algorithms by those in power, from the UK Education Secretary to the ruling classes in general. Similarly, the eventual winner of Twitter's Algorithmic Harms Bugs bounty, Bogdan Kalinic, a researcher based in Switzerland, expressed regret about how the competition was named. In a series of tweets, he noted that, quote, algorithmic harms are not only bugs. A lot of harmful tech is harmful not because of accidents or unintended mistakes, but rather by design, end quote. Platforms can cause harm, Kalinic said, not just through particular biased algorithms, but through their overall design. Design that maximizes engagement and generally draws profits on costs externalized to others. We can perhaps extend this to the more general rise of algorithmically driven personalization, mentioned earlier. In his 2019 book, Are Filter Bubbles Real?, Axel Bruns argues that, quote, a moral panic about social media in themselves, independent of how and by whom they are used, is not more warranted than one about TV, radio, or the printing press. There is no evidence, Bruns says, that the echo chambers and filter bubbles that seem to predominate today are primarily caused by technical systems. Quote, we cannot absolve ourselves of the mess we are in simply by blaming technology, end quote. These arguments do not necessarily clear away a problem often observed in relation to algorithms. That how they work, and therefore how they interact with the social milieus in which they operate, is fundamentally opaque. Frank Pasquale, in his 2015 book, The Black Box Society, points out that it is not just that we do not know the inner workings of algorithms. It is also that we know so little about the data and the private corporations that connect and feed into these algorithms. We need, he says, to be able to connect these dots if we are going to have any hope of placing limits on how these algorithms are deployed. And yet, as Taina Bucher argues in her 2018 book, If, Then, we should be careful of invoking the black box as an all-encompassing problem. Often implicit in narratives about black boxes are Enlightenment ideals that, by revealing the inside of the box, we can attain control. Bucher suggests we ask a cautionary question. Quote, what if the power believed to emanate from algorithms is not easily accessible simply because the idea of origins and sources of actions that come with the Cartesian assumption of causality are problematic to begin with? End quote. Bucher suggests that researchers need to find creative methodological responses to know what they can about algorithms. And along the way, they should also pay attention to the social processes which treat algorithms as these stable, tightly boxed artifacts, making indelible marks on the world we live in. There is a key question here. How should we respond to social or political problems which seem so closely tied with particular technologies, like algorithms? Just how far can revealing the inner workings of a technological artifact take us? Mike Ananny and Kate Crawford, in a 2018 article in New Media and Society, point out that too much stock is put into the normative ideal of transparency. Making an algorithm, or even its underlying data, visible does not automatically make them more accountable when, for instance, they seem to cause harm. Ananny and Crawford take a deeper dive than we can here. They discuss how the limits of the transparency ideal might actually be used to build a model of algorithmic accountability. But there is a more general, if still important point for us to pick up on here. We should think about algorithms, both what they are and how they are talked about, as always already tied into assemblages. Assemblages of associated technical systems and data, but also cultural norms, practices, and institutions. In our next and final episode, we consider a related but different assessment of where we are today. That our predominating media technologies are linked with the evolution of late capitalism. So, until then, I'm Scott Rogers, and you've been listening to Media, Technology, and Culture.